Welcome to PV System and Electrical Components. In every solar PV installation, from a 1 kilowatt rooftop system to a 200 megawatts utility scale plant, electrical components form the nervous system of the entire plant. These components ensure that the electricity we generate travels safely, efficiently, and reliably from the PV modules all the way to the load or the grid. In this module, we will explore different types of cables used in PV systems, the role of MC4 connectors and their proper handling, how DC-DBs and AC-DBs manage and protect power flow, different circuit breakers used on DC and AC sides, proper cable dressing and management techniques, critical safety practices and international standards. By the end of this video, you will clearly understand what makes a PV system not just functional, but safe, reliable, and long-lasting. Let's begin with the lifelines of the solar PV system cables. Electricity generated by solar modules must travel across long distances through harsh outdoor conditions, often for 25 years or more. Therefore, choosing the correct cable type, size, insulation, rating, and installation method is absolutely essential. We will now break cables into 5 major categories used in PV installations. DC cables carry direct current from the solar modules to the inverter. They are exposed to harsh sunlight, moisture, wind, and temperature variations. Key characteristics include tinned copper conductor for better corrosion resistance, fine strands for flexibility, XLPE or XLPO insulation for high temperature resistance, UV-resistant outer sheath, short circuit temperature rating up to 250 to 280 degrees Celsius, service life of 25 plus years. These cables must also maintain stable performance under varying current due to irradiance fluctuations. The most widely used standards are UL4, 703, TUV2, PFG 1169, and IEC 62930. AC cables carry alternating current from the inverter to the grid or loads. Selection depends on voltage and current ratings, single-phase or three-phase output, length of run to manage voltage drop, environmental exposure, conductor type, copper or aluminium. Longer cable runs require larger conductor size to minimize losses and maintain system efficiency. AC cables may have XLPE, PVC, or LSZH insulation depending on the application. Earthing cables are critical for protecting equipment and personnel. They create a low-resistance path for fault currents and lightning discharge. Materials commonly used include bare copper, GI strips, copper-clad steel, green/yellow insulated grounding wire. Chemical earthing, using compounds such as bentonite, is widely used to achieve stable, low resistance. Control and communication cables. These cables carry monitoring and control signals, not power. They ensure seamless operation of inverters, string combiners, trackers, weather stations, remote monitoring systems. Common types include shielded twisted pair RS485, fiber optic cables, control signals for trackers, battery cables used in off-grid and hybrid systems. Battery cables must handle high DC currents. They are flexible, thick, and have double insulation for safety. Connectors ensure safe, reliable, and weatherproof connections, especially at module level. The MC4 connector is the global standard. It supports up to 1,500 volts, locks securely, and is rated IP67, IP68 for outdoor protection. Proper crimping is essential. Loose crimping increases resistance, heat, and fire risk. DC distribution box, DC-DB. Located between solar modules and inverter, the DC distribution box protects the DC side. It typically includes DC fuses, DC MCB/MCCB, surge protection device, SPD Type 2/3, DC isolator, monitoring equipment. Purpose: isolate strings, protect inverter from surges or faults, provide safe maintenance access. AC distribution box, AC-DB, located after the inverter. The AC distribution box manages AC output, includes ACMCB/MCCB, ACSPD, isolator, energy meter, changeover switch in some systems, purpose, protect AC circuits, ensure safe grid connectivity, enable metering and isolation. Circuit breakers protect electrical circuits from overcurrent and short circuits. Major types used in PV systems. MCB, miniature circuit breaker, for small loads, low current circuits. MCCB, molded case circuit breaker, higher current, adjustable trip, used near inverters. RCCB/ELCB, earth leakage protection for personnel safety. DC circuit breakers, specialized arc extinguishing chambers to break DC arcs. VCB, vacuum circuit breaker, used in utility-scale high-voltage substations. Good cable dressing is a hallmark of a professional solar installation. It improves safety, heat dissipation, inspection, maintenance, plant aesthetics. Best practices include keep cables in straight runs, avoid tight bends, maintain correct bend radius. Use UV-resistant cable ties. Avoid sharp edges. Leave adequate slack for expansion. Use clearly labeled cable tags. Ensure proper grounding. Methods: underground, direct burial conduits, duct banks. Above ground, cable trays, raceways, catenaries, panel-level clips and clamps. Stainless steel/UV resistant. PV plants must comply with strict national and international standards. Key standards: IEC 61215 PV module performance, IEC 61730 PV safety, IEC 62548 system design and installation, IEC 603-64771 2 wiring rules, UL 4703 PV wire, NEC Article 690 PV system installation. Safety practices include proper PPE, LOTO procedures, insulated tools, earthing and bonding, surge protection, avoiding work during rain, storms, or extreme heat, fire safety and emergency response plans. Every cable, connector, distribution box, and breaker plays a critical role in ensuring the safe and efficient flow of electricity in a solar PV system. Understanding these components empowers installers and engineers to design high-quality, high-performance systems that last for decades. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.